Good morning, friends. Today we will go through the operations of a linked list. So, what we are going to do is we are going to create a node. We have an initial condition will be there. Condition we are going to slightly modify. So, first condition is we are not going to use a head node. Instead of this, I'm going to use a head point because I already said head node is a node contain the address of the first node. So why should we allocate a head node for that? Because we know that for storing the address, we have pointers. So I'm going to use head pointer. Only difference is head pointer is a pointer that stores the address of the first node. Same thing. Okay, I'm going to implement like this. Okay, we are going to see the different operations of same list. First operation is insert first. Okay. So I want to insert the element into the linked list. So already I said head is a pointer that can store the address of the first node. If head pointer head is set as null, that means list is empty. Okay. So create node is another function. It is used to create a node. So it will allocate the node space for us. Okay, we are simply going to call the function create node to allocate some space. Here we will have the space of a value and a link. So what we will do is we will clear this. Okay. What it will do, it will allocate some memory space, and memory space can hold a data field will be there and a link field. Here we can store some values, and here we can store the address of the node. This is status. I already said if the list is empty, head pointer or head link will be null. So I'm going to use head pointer. So if head is null, then that means list is empty. So list is empty. Then what should I do? Let's see the example. Okay, so this is my head. This is my head, and this is pointing to null. What I want is head should point to the address of this node. Suppose this node address is 1000. Okay, this is 1000. I want to allocate some space. So what I have to do is I want to make this head. I am going to erase this. I want to erase this value. Instead of making null, what I want the address of this value. Okay, this is 1000. I will make this as 1000. Then head will be pointing to 1000. So we can go to this location. From head, the link should be null. That's important fact because last node should be null. Here only one node is there. So what we'll do is we'll make this link field null. This will be pointing to null. And I will store the value here. Some value, suppose the value is 10. Is being stored. It will be like this. Okay, so that's the statement here I written. If head is null, we'll make head equal to new node. Means head will store the address of the new node. Then new node link will be set as null. Okay. If the list is empty, we can do this. If the list is not empty, what we have to do? Again, we'll call the function create node. It will allocate some space and some value will be stored in the data part. Okay, so we will have another node will be here. It will have some memory location value 20, suppose. Store the value as 20. So address location of this one is 2000. Assume it as 2000. So I want to add this 2000 to the first position, to the list. Here list will have 1000. So from 1000 it is going to null. That's the set. So what I want is, I want to erase this. Okay. Suppose if I erase this, what happens? That I simply erase this. Simply erase this and put the value as 2000. What will happen is, it will go to 2000. From 2000, it should go back to 1000, but it is not happening. We don't know the address of 1000. So what we will do is, we will not simply remove this. Instead of that, okay, we will first of all allocate the space, this link. Okay, what we'll say is that we'll make new node link as head address. Head address is 1000. Okay, then we will erase this. Then we will erase this and put the address of new node here. What happens is that from head we can go to 2000. From 2000 we will read the value of 20. From 20, is there any value? Yes, we have to go to 1000. From 1000 we are not going to anywhere. So it's inserted. 2000 is added in the, that's the point. Let's see here, new node link. First I'm going to take that one. That's the main thing. If we try to change the head initially, we lose the values. Okay, new node link equal to head and head equal to new node. Let's see one more example. I want to insert one more. I will create the node. I will insert the value. Suppose this is 3000. So what I will do is, we'll make new node link equal to head. Okay, new node link is here. So new node link equal to head. Head have 2000. So that will be head. This is 2000. I will get this as 2000. Then I will new node link equal to head. Then I'm going to erase this. This link will be erased and set it as 3000. What happens is that from head we will go to 3000. From 2000, 3000 is going to 2000. From 2000 is going to 1000. So it's inserting first. This is actually the insert first. Very simple code. Okay, insert first. We will create the node. Okay, we will add some value to the new node. We'll check if the head is null. This is empty. What we'll do is, we'll put head equal to new node. Then new node of link will be set as null. So else new node of link equal to head